Coming to the next type of problem, here the components attain the steady state condition. The switch is changed from position 1 to position 2 at t equals to 0. Steady state condition having reached before switching. So this is a different type of problem. Type changes from here. Question is again the same. Find the values of I di by dt and d square I by dt square at t is equal to 0 plus. The diagram given is so this is 20 volts, this is position 1, position 2, 10 ohms, 20 ohms, 10 microfarad. I of t is flowing in this. So we need to find I di by dt, d square I by dt square. So first the steps remains the same. At t is equal to 0 minus, the switch is at position 1, so I redraw the circuit. 20, the switch is at position 1. Now what the question is, what will happen to the capacitor? Since the circuit is getting completed, we will find the open circuit voltage across the capacitor. In this case the switch is closed, current is not flowing, but we can find voltage across the capacitor in this case. So I can say, suppose this is I of t flowing into this, so I at 0 minus will be 0, but voltage across capacitor at 0 minus will be 20 volts. So this is the difference between the steady state attainment and the normal problem. Here initial voltage across capacitor is not 0, capacitor is initially charged to 20 volts. Now what will happen at t is equal to 0 plus, that is when the switch changes its position. So now the switch is at second point, and instead of capacitor now we'll show it as a voltage source of 20 volts. Current flowing is I of t. This is 10 ohms, this is 20 ohms. So capacitor will act as a voltage source which will provide some voltage to the circuit. So I can find I at 0 plus will be 20 upon minus 20 upon 30, or you can say minus 2 by 3 amperes. So we have got I at 0 plus 2 by 3 amperes. Now we'll draw the circuit for t greater than 0. Now there is small change in this. T greater than 0, 20 ohms as it is, 10 ohms as it is. Now a voltage source will come in series with the capacitor. Initially we used to draw only the capacitor. Now the voltage source of 20 volt will come in series with the capacitor. Now I'll apply KVL in the mesh. So it will give me minus 30 into I of t minus 1 upon 10 into 10 raised to minus 6 integral 0 to t I dt minus 20 is equal to 0. So this is equation 1. I'll differentiate it with respect to t. So it will give me minus 30 di by dt, then minus 1 upon 10 into 10 raised to minus 6 I is equal to 0. This will be constant, will get to 0. So I know I add 0 plus, so I can find minus 30 di by dt will be I upon 10 into 10 raised to minus 6. So again I we have got it as minus 2 by 3. So we'll substitute I here. So I can say di by dt will be 1 upon 30 into 10 into 10 raised to minus 6 into 2 by 3. So I'll get di by dt at 0 plus as 2.22 into 10 raised to 3 amperes per second. So I've got di by dt. Now last task is to find t square I by dt. So I'll differentiate this equation with respect to t. So I'll get it as minus 30 d square I by dt square minus 1 upon 10 into 10 raised to minus 6 di by dt equals to 0. Or I can say minus 30 d square I by dt square is equal to 1 upon 10 into 10 raised to minus 6 di by dt at 0 plus is 2.22 into 10 raised to 3. So finally d square I by dt square at 0 plus will be 7.4 into 10 raised to 6 ampere per second square. So these are the values of I di by dt and d square I by dt square.